everyone, I'm Anya. I'm in charge of business development at KMs. And before we dive in, just a quick reminder to follow our LinkedIn page. It's the easiest way to stay up to date with our latest news and upcoming webinars. I also want to take a moment to thank you all for being here today. Your support really means a lot to us. So today's webinar will focus on key strategies for challenging mining operations. I'm thrilled to say that we have a special guest today. It's Ian Pearce. He's an independent director and advisor with a wealth of industry experience. Ian will be sharing his expert insights on navigating complex mining challenges. And also be sure to check out our upcoming podcast with Ian. We'll dive into a broader conversation about unique challenges small companies face in staying afloat while managing mining operations. So please don't miss it. So let me start by giving you a quick introduction to K-Mine. We began our journey back in 1994 in Ukraine, and since then we've grown to have a presence across Europe, United States, and Canada. Our team is a diverse mix of developers, geologists, mining engineers, including experts that are certified in JORC and NI 43-101 reporting standards. And we work with clients of all sizes, from small exploration teams to large corporations, and our focus has always been on delivering high quality but cost-effective solutions. Our core focus is our software, designed specifically for mining industry to support every stage of a mining project, from late exploration all the way to full-scale production. It's made up of 12 versatile models that work for both for open pit and underground operations. And what really sets our software apart is its adaptability. Whether you're running a small operation or a large corporation, you can pick the models that fit your workflow, whether it's just one or all 12 models. Our models also cover everything from geological data processing, surveying, to creating optimized mining plans for both short and long-term projects. With integration options for IoT devices or dispatch systems, our software enables real-time monitoring to help you make a quick and data-driven decisions. But our product is built on real-world industry experience and it's designed to address the challenges that we've encountered in our consultancy work, which we currently provide as well. As I mentioned earlier, we have qualified persons on our team who deliver reports that meet NI 43-101, SK 1300, JORC standards, tailored to different project stages like pre-feasibility stage, feasibility, DFS, mineral resource estimation, or preliminary economic assessment. And we specialize in a wide range of hard rock commodities, including critical minerals. So if you'd like to learn more about our services and how we can support your project, please feel free to drop a comment below or reach out to us through our website. We have a contact form there. So if we look at our agenda, we'll start by looking at how complex geological conditions affect mining operations and challenges that come with developing deep-seated ore deposits. From there, we'll discuss strategies for navigating harsh climate conditions and overcoming the logistical hurdles of working in remote locations. We'll also explore ways to address complex hydrogeological conditions that disrupt operations. For startups, we'll cover some innovative strategies to help them succeed. Then our guest, Ian Pearce, will share his insights from corporations in navigating these conditions. And lastly, we'll talk about a few extra steps you can take to enhance the overall efficiency of your mining projects. Mining in tough geological conditions can be a real challenge, affecting both safety and profitability. These conditions can include variable rock strength, fault zones, high ground pressures, and presence of water, all of which require precise and adaptive mining techniques to manage it effectively. One of the primary concerns with mining in such environments is the increased risk of ground instability. This can lead to rock bursts, collapses, and landslides, potentially causing injuries, damaging equipment, and halting production. Economically, the unpredictability of these conditions often leads to increased costs due to the need for additional support structures or more comprehensive monitoring systems, and sometimes slow production rates as safety measures are implemented. To address these challenges, real-time geotechnical monitoring has become a cornerstone of a modern mining operations. By using technologies such as microseismic sensors, ground penetrating radar or GPR, and laser scanning, mining companies gain critical insight into ground stability. These tools provide continuous updates on stress distribution, displacement, and the formation of microfractures, allowing operators to react before minor instabilities evolve into catastrophic failures. For example, implementing a comprehensive geotechnical monitoring program can reduce the risk of unplanned ground collapses by up to 30%, potentially saving millions in repair and downtime costs. Thanks to advancement in monitoring software, we now have a predictive analytics that gives us a better picture on long-term stability trends, helping improve on-site decision-making. Installing advanced ground support systems is another critical method to manage instability in complex geological settings. These systems include cable bolt, shotcrete, and steel mesh, which provide immediate reinforcement to unstable rock masses. In areas with high stress or seismic activity, dynamic ground support systems are used to absorb the energy from sudden rock bursts. Studies indicate that proper ground support can reduce incidence of rock falls by 40 to 50% and significantly lower the cost associated with downtime and equipment damage. For example, the South Deep Mine in South Africa has successfully implemented advanced ground support techniques. It improved safety and maintained operational efficiency even in high stress conditions. Automated equipment and robotics have revolutionized mining operations, particularly in geologically challenging settings. Remote controlled digging rigs, robotic bolters, and autonomous haul trucks not only enhance precision, but also significantly improve worker safety by reducing human exposure to hazardous areas. For example, using autonomous drills can achieve up to 20% greater accuracy in drilling patterns, which translate to improved ore recovery and reduced dilution. Furthermore, robotic systems are capable of operating continuously, leading to productivity gains up to 30% in underground mines. The upfront cost of automation, yes, can range from $1 million to $5 million, depending on the scale of implementation. However, the operational savings and safety improvement quickly make up for this cost, making automation a key part of modern mining strategies. One of the most effective solutions in managing complex geological conditions is controlled microblasting, which offers unparalleled precision in material removal. Unlike conventional blasting methods, microblasting uses smaller, highly calibrated charges that are tailored to the specific geotechnical conditions of a site. By integrating high-resolution geodata and advanced simulation software, this method minimizes vibrations and shock waves, reducing the risk of destabilizing surrounding rock formations. Studies have shown that controlled microblasting can lower the incidence of secondary fracturing by up to 50%, which is critical in maintaining structural stability. Additionally, the precise energy distribution allows for a reduction in outbreak by as much as 25%, leading to significant cost savings in scaling and support installation. This technique is particularly effective in areas with fault zone or layered geology, where traditional blasting might exacerbate weakness. The implementation of controlled microblasting typically costs 10 to 15% more than standard methods. However, the reduction in operational risks and delays can improve the overall project efficiency by 20%. Moreover, recent advances in digital blasting systems have made it possible to simulate blast outcomes with 95% accuracy. That ensures optimal results and further reinforces the role of microblasting as a game-changing technology in mining. For example, a study at a larger copper mine showed a 15% reduction in the blasting costs and 20% decrease in the volume of explosives used while still maintaining rock fragmentation quality. This is not only leads to cost savings, but also significantly reduces the environmental impact of blasting operations. In controlled microblasting techniques, conventional explosives are used, but with advanced detonation methods. This allows for precise control over how the energy is dispersed, and this approach allows for the precise breaking of rock, minimizing unnecessary vibrations, and enhancing safety in sensitive geological environments. This careful management of explosive energy is crucial for maintaining structural integrity and minimizing environmental impact during the blast process. The development of deep-seated ore deposits present a unique set of challenges, including High ground pressures, increased temperatures, logistical difficulties, and significant ventilation requirements. These challenges not only heighten safety risks, but also drive up operational costs, often requiring specialized techniques and technologies to maintain both productivity and worker safety. In situ leaching, although less common, but has emerged as a viable alternative for certain ore types such as uranium, copper, and lithium, and maybe even some gold deposits. This technique involves injection leaching solution directly into the ore body and dissolving the available metals, which are then pumped to the surface for recovery. The primary advantage of this method is its minimal surface footprint and the absence of traditional mining waste such as tailings and overburden. This method can reduce operating costs by up to 30% compared to conventional deep mining methods, and particularly suitable for deposit in permeable rocks with low economic viability for traditional mining. However, it does require precise hydrogeological understanding and careful management of environmental risks, particularly in groundwater contamination. And projects such as Crow Butte uranium mine in Nebraska have demonstrated the economic feasibility of in situ leaching, achieving consistent production with reduced environmental impact. Another innovative approach involves the use of high-performance tunneling systems, such as tunnel boring machines or TBMs, which are increasingly being adapted for mining applications. Traditionally, it was used in civil engineering, but in mining, TBMs offer significant advantages in deep mining by providing rapid and continuous access to ore zones with minimal ground disturbance. These machines can excavate at rates of up to 50 meters per day in favorable conditions, which drastically reduces development timelines compared to conventional methods. Although TBM deployment is capital intensive, it costs from $5 million to $15 million per machine, but the long-term savings in labor, safety, infrastructure makes it attractive option for large-scale deep-seated deposits. The Grasberg block cave mine in Indonesia, for example, employs TBMs to create access tunnels, showcasing their effectiveness in large-scale underground mining. Block caving, however, remains one of the most efficient and widely used methods for deep ore extraction, particularly for massive ore bodies with favorable geotechnical conditions. This method relies on natural gravity-assisted ore movement, significantly reducing the need for extensive drilling and blasting. Recovery rates with block caving can reach from 75 to 90% depending on the shape of the ore body. This makes it one of the most cost-effective options for deep deposits, with production costs usually ranging from $10 to $20 per ton. However, block caving requires significant upfront investment in infrastructure and lengthy preparation period. Preconditioning the rock mass through methods like hydraulic fracturing or induced stress relief can take several years, with total project timelines from design to production averaging 7 to 10 years for large-scale operations. Mines like Cadia East Mine in Australia or the El Teniente Mine in Chile have successfully implemented block caving, demonstrating its potential for handling depths exceeding 1,000 meters. Cadia East, for example, achieved operational success despite challenging ground conditions, leveraging advanced monitoring systems to track ground subsidence and ensure safety. Additionally, modern caving techniques now integrate predictive modeling and real-time monitoring, reducing risk and optimizing ore recovery. Mining in extreme climatic conditions presents a complex challenge faced by many mining companies worldwide. These conditions can include intense heat, cold, high humidity, or extreme dryness, each imposing special requirements on equipment and infrastructure. The problem is exacerbated by the fact that the standard equipment often cannot operate effectively in such conditions, which leads to increased maintenance, repair costs, as well as productivity losses. One way to address this problem is through the use of modular construction. Companies like Modular Mining Systems are known for their innovations in this area. They offer solutions that allow for assembly of buildings from prefabricated models and significantly reducing the time and cost of construction in locations with extreme climatic conditions. This approach also minimizes the need of work in harsh weather conditions, enhancing safety and reducing health risks for workers. To protect equipment from extreme temperatures, companies are using innovative materials like high-strength alloys developed by DuPont. These alloys can handle extreme temperatures without losing their performance. For example, the Zero series alloys are highly resistant to high temperatures and aggressive chemicals, making them an ideal choice for use in hot and chemically aggressive environments. To reduce this risk and optimizing operations in such conditions, companies are making decisions aimed at improving the durability and reliability of their equipment. For example, the use of specially designed trucks and dump trucks from Caterpillar, Komatsu, Volvo, and other companies which are equipped with climate control systems and reinforced components allows maintaining productivity even at very low or very high temperatures. Energy efficient technologies also play an important role in adapting to extreme conditions. Systems like Daikin heat pumps, which operate effectively even at very low or high temperatures, can significantly reduce heating and cooling costs. These systems can provide a 30 to 50% reduction in energy consumption compared to traditional climate control methods. Working in remote and inaccessible areas present significant logistical challenges for mining companies. Transporting ore and other materials through such terrain is typically associated with high costs and complexities that can significantly increase the overall cost of operations. One key approach is the deployment of modular construction techniques for building infrastructure in remote areas. Modular facilities, prefabricated off-site and assembled on location, reduce construction timelines by up to 50% compared to traditional methods. Additionally, these structures are often more cost-effective and can be relocated and expanded as needed, providing flexibility for dynamic mining operations. Reliable energy supply is also a critical factor, and microgrid systems are powered by renewable energy sources are becoming increasingly popular. Solar, wind, and hybrid power solutions reduce dependence on fuel deliveries and lower carbon footprints. These systems can supply up to 90% of a mine's energy needs under certain conditions. And for example, the Agni Gold Mine in Australia uses a 50 megawatt renewable energy microgrid to power its remote operations. One innovative approach to solving transportation problems in challenging conditions is the use of the RobCon conveyor system. This type of transport offers a unique combination of a suspension system and belt conveyor, which allows the transportation of ore through the air, bypassing natural obstacles like rivers or mountain ridges. And the use of RobCon not only reduces environmental impact, but also significantly decreases the need for road construction, which usually requires substantial investment in time. Statistically, the RobCon system can reduce the cost of transporting ore by up to 50% compared to traditional road transport methods. Additionally, this system can handle up to 25,000 tons of cargo per day over distances up to 5 kilometers, making it exceptionally effective for large-scale operations. Savings are not only limited to transportation costs, but also in reduction in fuel use and CO2 emissions, which makes RobCon an excellent choice for companies aiming for sustainable development. In the project using the RobCon conveyor systems in Mexico, the terrain's unique features were considered, and this includes its complex relief and distance from major transport routes. And building traditional roads in such conditions is not only extremely costly, but also technically impossible due to the geological and topographical complexity of the territory. These factors made RobCon the optimal solution for transporting ore, and the system provides transportation of resources across mountain barriers and valleys, bypassing natural obstacles, which would be impossible with conventional vehicles. Mining in areas with complex hydrogeological conditions present a significant challenge for the mining industry. The presence of waterlogged rocks or permafrost requires companies to implement specialized technologies and approaches to ensure safety and efficiency in mining operations. Water and ice not only complicate access to minerals, but also significantly increase risks to infrastructure and personnel, as well as elevate the cost of mining operations. The first solution is the use of high-capacity dewatering systems, which involve strategically placed pumps and drainage wells to remove water from the mining area. Modern dewatering systems can handle flows exceeding 10,000 cubic meters per hour, ensuring continuous operation even in heavily waterlogged conditions. Mines like the Finch Diamond Mine in South Africa have effectively reduced downtime using the automated pump systems integrated with remote monitoring for real-time flow adjustment. The approach is the implementation of advanced grouting techniques to seal water-conducting fractures and stabilize grout conditions. Pressure grouting using cement-based or chemical grout that creates an impermeable barrier, reducing water inflow by up to 90%. This method has been successfully employed in Hydrogeological gold mine in Australia, where grouting reduced seepage rates and ensured safety and more stable underground operations. Another solution involves constructing water diversion and storage systems to manage surface and groundwater flows around the mine. Techniques such as diversion tunnels, setting ponds, or retention basins help to control water levels while preventing environmental contamination. The Okitedi mine in Papua New Guinea, a comprehensive water management has mitigated flooding risk during seasonal rains, ensuring consistent ore extraction and minimizing downstream impact. The other very effective methods for operating under such conditions is the use of freeze wall technology, as implemented in the freeze wall construction project in Saskatchewan, Canada. This project demonstrates the use of innovative techniques to create an artificial frozen wall around the mining site, which blocks water penetration and stabilizes the soil. This approach not only prevents mine flooding, but also significantly reduces risk associated with thawing permafrost, which is especially important in the context of global warming. The freeze wall systems involves drilling wells in the required depth around the perimeter of the area being developed and installing pipes through which a cooling agent is circulated. This leads to the freezing of the surrounding moisture of the soil, creating a solid barrier that prevents water seepage. The project in Saskatchewan showed that such a wall could reduce water penetration by 90%, providing a stable and safe conditions for mining. The technology of freeze walls also allows for significant reductions in the cost associated with the continuous pumping of water from the mines, which is an expensive and energy-intensive process. Also, soil stabilization reduces the likelihood of collapses and other geotechnical problems, further enhancing the safety of operations. The application of this approach demonstrates how modern technologies and innovative solutions can help overcome complex hydrogeological challenges, making it possible to mine minerals in conditions previously considered unsuitable for development. This opens up new opportunities for the mining industry, allowing for efficient and safe operations in the most challenging and extreme conditions. And now joining us, our guest, Ian Pearce, who is independent director and advisor. He has a lot of experience working with major corporations and also small companies. So he would give you some insights about what can be the technologies to overcome challenges when it comes to different type of conditions, whether it's natural conditions or like logistical conditions and stuff like that. So Ian, go ahead.
Hi, thanks very much, Anya. Good to meet you. Yeah, I think when you look at mining, one of the biggest things we're always managing are uncertainties, and it starts from when you look at the geology. You drill off the deposit. Your drill spacings are usually pretty wide because it costs a lot of money, and it really is around how do you use that data or that information to get better control as you move that drilling from a resource into a reserve, which is really the economic position you want to be in, where you say we can make money on it. We cannot make money based on the deposit. So I think that's the reality of mining. Has been that way for forever. But I think in today's world, and I call it the digital revolution, I think there's a lot of exciting tools and processes one can use in mining space to run your businesses, define your businesses, and run your businesses very, very differently.
What would be the strategy, I guess, like when you have already operations or like you establishing the operations, right? Like you have short-term challenges and you have like long-term challenges. What would be the strategy to overcome, let's say, short-term strategy, like short-term challenges, and what would be the what would be the priority list, I guess, how to manage that?
Well, I'd say that, in most mining companies, your biggest costs are around labor and energy. So in a short term, you'd really want to understand how you can actually affect that. So you'd want to draw up what I call value driver trees around those aspects, and then decide what are the areas that you can focus on. Where's the biggest bang for your buck? How can you optimize? And that also goes about really, probably when you're in that situation, you have limited access to capital. So it's really around making sure that you're putting capital where it's bringing you the most benefit. So in the short term, it's really around trying to manage um, the efficiency of the operation. And ideally, what you're trying to do as well is all operations are mapped on a cost curve. So for every commodity, for every supply, there's a cost curve, whether it be copper, whether it be nickel, whether it be whatever commodity in, all producers will fit on a cost curve. And typically in the short term, you want your business to be resilient through the cycle. So you want to move yourself to the lowest point on the cost curve as possible. So you need to look at those levers that can actually move you down that cost curve. And as I said, the first lever in the short term, I'd say, is really looking at how can you do things more efficiently. So really looking at efficiency as such. And again, this digital world offers us many tools where before many operations were done manually and not integrated. And today you can integrate decision trees by doing it through automation or through a digital platform.
And if we talk about, major companies, we talk about corporations, they don't really have like problems of budget, right? Like but what are the challenges that they facing when it comes to mining operations, especially when it comes to mining operations in challenging environments? And it's my understanding even though they have this unlimited budget, they do not implement all of these like innovations that can help them actually operate efficiently. Why is that? And what would be, I guess, the advice to major corporations in this sense? Like if anybody was listening to us who is a manager and who can actually make a change in terms of their corporation to operate it more efficiently.
I do quite a lot of work with startups, and one of the things I've found is when you're looking to find a customer who's willing to talk to you about technology, you must find a customer who's in pain. And there's a very good book written called Good to Great. And one of the biggest evils of great is good. So with many of these companies, because they're making money, things are good, things are okay, there's nothing problematic. There's an inability to desire to be great, because good is good enough. And I think that's a challenge for leadership, and that's where leadership has to come in. I always believe that a manager's role is to create constraints for their teams so they can be innovative about finding solutions. I don't think
they should have a purpose. They should have a purpose
exactly.
to overcome something at least.
Exactly.
Because
I
there's
mean,
no development without crisis.
yeah, I think you've got to, they always talk about the burning bridge or the burning platform, right? So I think management's or leadership's job in those situations where things are comfortable and everything's running very well and everything's good, you need to create constraints to motivate people to think about things differently. And when you have those constraints, you have to think outside the box, how to solve these problems. I think the other thing too is there was a bit of a panic a few years back when suddenly everybody realized, we had this warming up of our planet, and people wanted to address that. But and if you just ignore that and just say we need to run our businesses more sustainably, if you just had to say that, people have come to terms with how to get to 2030, but I don't think people have started to think about how to get to 2050. And I think to get to 2050 is a very different picture. And I believe that to get to 2050, we need new knowledge. We need new ideas. We need new ways of doing things. And I think that's something that a lot of people haven't started to think about, again, because we are so focused on that next quarter, we're focused on that next half year result or whatever the case. We're so focused on the short term that it's very difficult for teams that are very lean and very small to sort of lift up their heads and think about that long-term picture. That'll be challenges we have to solve today to be able to get to 2050.
Is there any technologies that is now trending with this within corporations that, let's say, small companies can't afford?
I think there are technologies. I've mentioned this technology that's called that can be put in shovels. This XRF application package that gets put in shovels. I think that technology is available today, and basically you can buy that technology and pay as you go. So you don't have to have any upfront capital. It doesn't interrupt your business when the shovel comes out for maintenance. The application package gets put on the shovel, and the shovel goes back into business. So there are technologies like that which are in some businesses we're talking tens of millions, in some businesses we're talking hundreds of millions of difference in money a year. So when you think about those numbers, it can take a business that's a third quartile or a fourth quartile producer down to being a second or third quartile producer, which means they can survive the cycle. Or it could take a company that could be going out of business. It could keep them in business. Or even when you think about ore bodies, when you're able to do better control of your ore body, you might be able to change the cutoff grades and bring in a different configuration of that ore body and use more of that ore body because you've got better control of it. Where a lot of times you don't seem to have that control based on a very rudimentary block model approach. And so because you don't have that control, you work with a much tighter cutoff grade, where you might be able to release that cutoff grade. Or even if you use automation, you might be able to go through various phases of increasing or reducing cutoff grades because you've got knowledge and you can actually control it. So I think there's an example of technology. I think another example I'll give you is in the lithium space, because today lithium brines, the most proven way of extracting lithium is by putting them in these big salars, so these big ponds, and evaporating the water off and getting the crystalline material.
In situ.
There's a technology I'm associated with, which is actually looking at extracting the brine, absorbing the lithium onto an ion exchange bead, and then pumping the brine back into the ground or into the lake. So there's no evaporation needed. There's no environmental impact. And so I think there are those sort of technologies that are in development today, and they should be commercialized within the next 3 to 5 years. And those are very interesting technologies, which I think will address some of the environmental concerns that society has with what we do as miners.
What kind of technologies have you used, like in terms of innovations, I guess? Have you used any of like AI technologies, blockchain technologies, or anything like in your projects?
My role when I was a CEO in charge of business, I stopped doing that in 2013. So, as an advisor, you can only, as they say in the classes, you can take a horse to water, but you can't make it drink. So I have suggested to many of my companies the need to think about technology. I'll give an example. I was associated with a company that had a block cave mine. And as you know, with block caves, all your capital is up front because you develop the undercut, which beneath the ore body, and then you rely on the geotechnical aspects of the rock to collapse and come towards your draw points. And then based on your geotechnical model, you should be then drawing on various parts of the ore body based on that geotechnical model. I think that block caving is one of the earliest mining methods that you can automate and make it fully autonomous. And you could imagine that if you had on every shovel that went to every draw point, a sensor that could tell you what was the grade of the ore coming out of that draw point. So you would have now, because again, with a block cave, you drill it off, but once the cave starts to happen, you can try and predict how the rock is moving and coming down to your draw points. But it's a very imprecise method of trying to determine where the ore is going and where the dilution's coming from. But if you had a geotechnical model that informs you where you need to draw on the ore body, and then you had a geometallurgical model which actually looks at every scoop and every bucket of ore you take from a draw point and tells you exactly what the grade is there, you can then reconcile all of that through an automatic system. And then you should be able to say, I take one scoop from that draw point, I take two scoops from that draw point, I get three scoops from that draw point, and you could automate that completely by having autonomous vehicles going and actually doing that through a computer program. And so I have suggested that to a company that I was involved with. But, to your point earlier around why don't people want to do this, I think, they had a very lean management organization. They were very focused on solving some immediate problems. And so they just didn't have the capacity to lift their heads and see that maybe what was being suggested through automation like that was going to actually be a savior for them as opposed to extra work. And unfortunately, when you're running your business on a firefight mode, you tend to continue to firefight. You don't step back and say, let me plan better. Let me try and access some tools and try and improve the way I run my business.
So would you say that maybe not most, but would you say that companies that, let's say you are aware of all these technologies, you're aware of what kind of benefits these technologies can bring, would you say that there is resistance within the companies to actually think about it strategically, don't think about it in terms of short term, okay, today I don't need it, maybe tomorrow I also don't need it, but next month I might need it? Would you say that there is this type of resistance because of there is this old pattern of doing things and people don't really want to switch, even with the advisor like yourself?
No, I was a big time advisor, and yes, they wouldn't accept. So I think you're absolutely right there. I think there's an inability to see the advantage of these things. I think the other thing too, though, is one needs to translate some of these things into financial benefits, because you need to be able to pitch to the CEO and CFOs the value. So if you take consulting companies like McKinsey, Bain, all these, the 5 top auditing companies now, they are all selling services to the sectors, whether it be pharmaceutical, whether it be medical, whether it be even mining. And they're getting mining companies to pay them millions of dollars to consult. And so when you look at, and their pitch is always to the CEO, the CFOs, the sort of top echelons of companies. And their pitch is always in financial terms. So they make it very simple, and they show that cadre of leadership eye-watering numbers that they're going to deliver to the company. And I think that's where a lot of these technologies are falling foul, is they show technical solutions, but they don't show economic solutions. And I think you need to translate a lot of these technologies and these approaches into what does it mean to the bottom line, and you need to then pitch that to the C-suite, because when they see that pitch, they will adopt. And you've got to work it from the top down. At the same time, you've got to also build a relationship at operations, because they can actually sabotage your project if you don't make sure that they buy into. So you've got to work it at both levels, both at the operational level as well as at the corporate level. Make sure that the message has got across to both levels of the company.
Thank you, Ian. And also, in conclusion, I want to talk about how some companies in the mining industry are constantly finding new ways to optimize their operations, boosting performance while supporting sustainable development. By implementing innovative solutions, they improve all aspects of their work, from logistics to ore processing, water management, and land rehabilitation. Let's explore the extra strategies, extra steps they use to increase efficiency and economic returns, along with the extra steps they take to enhance performance. Some companies use underground drones as mine scouts. They fly through the mines to search caves, collect data, and aid in the mapping process. They've proven highly effective at recording gas levels, identifying geological features, and capturing high-quality visuals of the caves. This eliminates the need to send human surveyors into unfamiliar areas by using drones instead. First, workers are kept safe from possible hazards in an underground settings. After excavation, there are multiple risks like potential collapse, inaccessible areas, and no light. And the technology has been around only since 2017, but the possibility of understanding a mine's conditions without putting miners or surveyors at risk will be hard to resist. Another technology gaining traction is virtual reality. When you start a new position, it can be challenging, and employees often have strong theoretical knowledge but lack practical experience. This is practically risky, especially risky when working with explosives, where lack of hands-on training can be very dangerous. And with VR, miners can train in a simulated environment, practicing tasks like placing settings and detonating charges without any risk to people or equipment. Mistakes are flagged and reviewed, and turning them into valuable learning opportunities instead of potential hazards. The more automated mine is, the easier it is to collect data. The data includes everything from mine conditions to inventory to fleet maintenance needs. As more and more mines add automated machines to the process, more data will be collected, leading to improved analysis, operating efficiency, and safety. The majority of mining software available compiles and sorts data, storing it for easy access even remotely. With our software like KMine, equipment, operators, and management can track material usage and identify when the repairs are needed, helping avoid costly downtime. Even in the exploration phase, mining software is essential for efficient operations. Environmental data is stored to be reviewed by geologists and stakeholders to make decisions about a potential mine site. When it comes to operation optimization, blasting is also a key area. While much has changed in the mining industry, explosives remain crucial for successful blasts and efficient design. Companies are increasingly using technologies such as projected fragmentation models, ore tracking systems, and environmental data to create precise blasting plans. Drilling logs, visual inspection, and laser profiling data all contribute to informed blasting decisions. The blast site is analyzed through various factors like sediment density, fluid penetration, mud seams, and fragmentation. Blasting is a high-risk activity that requires specialized crews with others clearing completely the area. While blast sites aren't fully automated, electronic detonators are improving safety and performance. However, due to the complexity, wiring is still handled by explosive experts. The long-term goal for many in the industry is to create a wireless system for full automation only with human oversight required. Part of the process of automation also includes switching to all electric underground fleet. This is a slow process, but it's certainly in the works. The initial expense is high, prompting companies to think twice before purchasing, but electric vehicles provide a fairly quick return of the investment. As operating expenses are low, they've been proven to be more efficient than traditional fleets. Some vehicles you'll find in these electric fleets are boom trucks, LHDs, and mobile rock breakers. Fortescue Metal Groups, an Australian mining company, is also exploring the use of 3D printing with fine metal powders to make replacement parts. This technology could potentially produce up to a ton of parts a day, offering a quick and efficient solution for equipment maintenance. The company is working with 3D printing experts to design the machine, aiming to avoid stockpiling parts and waiting up to up to 18 months for replacement. They focus in on parts in their processing plants that are either need to be replaced or outdated. By printing parts on demand, they can cut down on costly downtime and reduce the need for a huge inventory. Plus, they have the flexibility to redesign parts that are not working well. So, as you can see, innovation in mining not only helps to save time and money, but also plays a crucial role in saving lives. Every new piece of data collecting improves safety. Every driverless vehicle keeps workers out of the harm way. Every advancement in scouting helps identify potential hazards before they become a threat. As the world demand for minerals grows, ensuring the safety and security of miners is more important than ever, and technology is key to making that a reality. So I think that's it for today. Thank you so much for joining, and I'll see you next time.